Yep. We're back. Right. Okay. Being a native code developer, I really care about some very specific set of things. Like, hey, I want to be able to look at call stacks that are from some release build and like that's maybe partially corrupted. And I care about SIMD intrinsics in the compiler, with lots of people who write other C++ code don't care about it at all. And I may care about certain things to do with multi-threading that other people don't worry about and so on. But Visual Studio, because it's marketed to this entire set, like developers that are doing all these million different things, like there's no one customer for Visual Studio, and that team tries to work for all of them. So it's kind of disingenuous to say like, oh, they could be doing so much of a better job. Like I only see I see Visual Studio through this very narrow aperture. And sure, like some of the things in there for me, like I would want them differently for the workflow that I have. But one thing that you learn if you do this kind of 64K intro things and just look over artists' shoulders a lot is that no two people use the same program the same way. Like one thing that is completely fine for one person is a completely unacceptable workflow for another. And that is certainly true for our tools. And it's also true for IDEs and a lot of other things. I mean, that's really a thing of market segmentation there. The problem is you have like, there's quote unquote a minimum viable Visual Studio, right? Like if it doesn't have at least this set of features, nobody would be interested in it. Like if you had an IDE that didn't even have a usable text editor, nobody would use it. And then you have these things like compilers and so on that they also ship that are kind of big. And it's just like the question is, if you did the product, that is just the thing I want, is there actually a large enough market there to sustain a team large enough to deliver that product? And it doesn't seem obvious to me that the answer is yes. Like if there were 5 different Visual Studios all focusing on a different part of the experience, I'm not sure that any of them would be able to survive. So like there's a certain problem there.
Okay.
So I don't think it's quite that simple. And certainly a thing that Casey loves to do is that Casey has a very, very specific problem that he wants solved. And he writes the tool that solves exactly that problem and exactly for him. And that's great. That's a very productive way to work. But certainly in Rad's case, what has also then happened is that he was on Granny or whatever, and then he hands off the project to somebody else. And somebody else has to live with the results of these decisions. And Granny has been working fine. But the whole point is like all these decisions that you initially made, assuming that like, oh, this just needs to be okay for me, since I'm the only programmer on the project. If you look at this thing, just not in terms of right now, but as rippling out as this wavefront in space-time, right? This is a program that's currently only on your hard drive. And then at some point you release it and other people in other places use it. And over time, somebody else needs to maintain it. Like these decisions you made that were initially just for your benefit and like you were the only person who cared about them, now influence what other people can or can't do and influence their work. So as soon as you start shipping code, you have that problem where these decisions you made do affect other people. And I don't think you can just, like, if you're just only developing a tool for yourself and never giving it to anyone, obviously that doesn't apply. But as soon as you say like, okay, like this is actually good enough that somebody else might want to use it and I'm just going to ship this, it is kind of an asshole thing to just say like, well, it is the way it is. Like, works for me, guys, works on my machine. Who cares, right? Because fundamentally, once you ship that code to somebody else, they're like, okay, I'm gonna spend, like Sean got into this point last week already, like they're gonna look at this and spend some time trying to get it to do what they want. Like say you have this image loader library and you read the docs and you try to integrate it and you hit some linking problem. and blah, 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 blah. 5 hours later, you decide that this is a disaster. Like, this is never going to work. It makes all these assumptions that you don't want, but it wasn't really obvious. And it was built with this compiler version that happens to be incompatible with yours. And it assumes a different C library, and it's just a mess, right? And you can go say, like, well, it works for me. It's not my problem, right? Like, for my workflow, this is totally fine. But by the point you've released that code and told people, like, hey, if you want to use that, you have at least some degree of responsibility for the experience they're going to have.
I see what you're saying.
And you can't just say, like, well, that's not my problem. I mean, you totally can, but it's a very egotistical point of view that I wouldn't necessarily subscribe to. And I'm not trying to paint Casey here as the villain here. And I said, like, Granny is working just fine for RAD.
Yeah.
And some of the stuff that I tend to rant about, like CDEP, build system, may not be, but it's also like build systems are just this thing that nobody's ever satisfied with.
Yeah.
So, like, don't take that too seriously. But, like, fundamentally, there's a large problem in my mind where there's a lot of code out there being shipped in a way that really shouldn't be. Like, especially, say, on Linux.
I was going to say.
You have just lots of code that is just bolted together with duct tape. Like, this is all held together by these 5 shell scripts, right? And once you touch anything unrelated in the system, it breaks for some reason that is completely unclear.
But it's open source. You can fix it.
Exactly. Like, patches will come, right? I was like, I don't buy that. That's not a healthy attitude to have either. Like, if you have this program that scratches your itch and that works for you, that's great. But once you decide to actually ship that and distribute that to a couple 10,000 other machines, you kind of have to broaden your horizon a bit and, like, actually think about how that thing affects other people and whether some assumptions you're making there might cost 1,000 people like 5 lost hours. And suddenly, like, if you've cost 1,000 people 5 lost hours each, that's 5,000 lost hours. That's a lot of lifetime.
Yes.
Like, I mean, like, in the grand scheme of things, like, in terms of, like, the consequences your actions might have, like, that's not a horrible thing to do, but it's not something I just say that you should just do either. Like, this is something to at least be aware of. And you can totally decide, like, this is a trade-off I made and I thought it was the right idea at the time, and maybe I was wrong. Like, it's totally fine to be wrong about that. But once you get with something like an open source package, once you get the feedback that everybody doing this seems to be having a terrible experience with it, like, it works on my machine is not good enough. Because at that point, like, if everybody ends up trying this and having a terrible experience, then your library that solves the problem for you just fine may actually be a net negative in the world. And that's not okay.
Okay, well, now that you say that, right, let's make this the official Q&A session. So guys in the chat, go ahead, and girls, go ahead and ask your questions with Q:, and I will start tracking them and voicing them to Fabian. And while you do that, while you write your questions, I'm going to ask you one more question, Fabian. You know, what you were talking about. So do you think, let's guide this conversation to what people do when they try to solve problems themselves, right? They're like, oh, there's a software that I believe will be useful and it can be much better than the one I saw from this other person in this other website or something like that, right? Are they, even if they're, you know, smarter or whatever, are they making the same mistake as the other people when they try to recreate this program? Or, because
that's a super important point.
Okay.
That one that I wanted to get into, like, from the beginning, like, I was thinking, what kind of stuff would I like to get into this interview? So I really like that you were asking me.
Let's make it happen. All right.
That's actually a really important point. So what a lot of people do is just look at something like, oh, this shit. Like, let's just rewrite this. Like, this is just bad. And because they have something with a program or library that they're really, really unhappy with, and that's fine, that's valid. Like, not working for me is totally cool reason to write your own thing. And the thing about this whole saying of, like, reinventing the wheel, it's like, actually, if you look at the evolution of the wheel over time, it's changed quite a couple times. Like, it used to be the solid slab of wood, and now we have these metal spokes with vulcanized rubber thing with air inside it around. clearly there's been some evolution and reinvention of the wheel going on. And like clearly these things are good for different things. But the important thing here is if you say like, I'm really dissatisfied with this thing and I want to rewrite it, that's fine. And that's totally valid. But it feels to me like a lot of people then immediately go to like, oh, from like, there's these 3 things about this library that I don't like. Like, let's just rewrite everything. And like clearly not a single design decision, not a single insight in this program can possibly have been useful. So like there's no value in me even learning how that thing works first before I'm gonna rewrite it, because clearly I'm gonna do so much a better job, right? Like clearly like by me having used this library and being dissatisfied with the 3 things it does wrong, like there's no need for me to learn about the 20 things it might have done right. And that's something like, this is a caricature, but you sort of see like that kind of attitude, like, oh, this is terrible. And often it's for the most superficial of reasons. Like, oh, like this program doesn't use the indent style I prefer. Like this is unusable code. And it's like, what the hell, man? Just like, there's a lot of people,
you're right.
It feels like they enjoy writing code a little too much.
Yeah, you're right.
So like their first thing is like, I've found an excuse to write a lot of code. And like they're not trying to figure out what problems that old code was solving. So what ends up like they do this rewrite, and like it goes great for the first 2 days, and then they bump into this problem. Turns out it's a problem the other library has solved, and they have a great way to do it, but you're not aware of that. So it's like, huh, and you're stumped. And then you kind of bumble your way through this, and that happens like 5 or 6 times. And you make these design decisions from a point of view of ignorance because you hadn't thought about it before. And now that stuff is kind of wonky, but it sort of is the way it is. And because you didn't think about it before, like there's some design decisions in there that really fight each other. So it's this weird thing. It's like, okay, that's just the way it is, and I'm going to ship it anyway. And then you generate this thing that the next person is going to look at. It's like, what the hell is this, right?
True.
Like, there's these 5 things in there that I really like, but there's also these 5 things that are completely terrible. So clearly, the solution here is to just rewrite this from scratch. You see, again, this is a caricature, but you actually see this a lot in open source projects, to the point where this has actually been named. Like, this is a thing. It's like called the Cascade of Attention Deficit Teenagers Development Model.
I've never heard that. That's awesome.
Jamie Zawinski, one of the original Netscape guys, named that after his experience with GNOME, when he discovered like he would use GNOME originally, like the 0-point release, and like he'd file a bunch of bugs that he'd run into during daily development. And he found out like the way these, like, filed these bugs, they sat around the bug tracker for 2 years, and eventually all got closed with like, yeah, these are not relevant anymore. We rewrote the whole thing for GNOME 1. And then for GNOME 2, for GNOME 1, he filed these bugs again, and they all got closed with like, oh yeah, we rewrote the whole thing for GNOME 2. So he had these recurring issues that he'd report every single time, and just they'd never get resolved. Because each project gets to the point, like the 0.8 release, he called it, where like it clearly does enough to be viable for a lot of people, but everybody's sort of unhappy with it. And at that point, it's just like, yeah, let's rewrite this. And you never get to a point where it's stable or where it actually works for most people. So like there's like, again, like writing code is fun, but at some point you gotta honestly assess this, like, is the right way to do this? Like, do I want to rewrite this because I actually like, I understand what this thing is doing and it's doing the wrong thing? Because that is the best reason to rewrite something. Like if you truly understand something and you look at this, like this is not actually solving the problem I need solved. And there's no solution out there that I know of, or I'm not aware of a solution, or I am aware of other solutions, but they have these trade-offs that are unacceptable. Or just I want to do this for my own edification or education. All of these are totally valid reasons to rewrite something from scratch. What is not okay is to rewrite something from scratch out of this position of ignorance. And then after that, not even taking a step back and looking at it as like, okay, this didn't work out the way I meant to. Like clearly I need to look at this and figure out where did I go wrong. But instead, you just blithely wander on. It's like, works well enough for me. Like the other people complaining are just whiners. As said, patch is welcome. and just go on and like cutting this whole leaving this trail of half-finished projects behind you. Like that's an attitude I'm really, really unhappy with. And again, like I'm sort of exaggerating here, but I don't think I'm exaggerating all that much.
Oh, well, so if I can extrapolate from what you've said, do you think a good suggestion for people who maybe want to consider even the fact of doing something from scratch because they think it'll be better is to maybe be more active, I guess, in reading other people's code bases and being familiarized with how other people have solved problems before they even consider tackling their own? Is that a good suggestion, you think?
Yeah, so that's something I've actually been advocating, and the thing is, this is actually hard. Like reading code is legitimately hard.
Yes.
It is a hard problem, and it's not like something like, first off, like reading code is difficult in a way that is similar in that, say, reading literary fiction is difficult, and that there's a lot of things being said in the code, but there's also a lot of things that are implicit, that are not stated outright, but that you need to keep in your head to like get a picture of what's actually going on, right?
Yes.
So like that stuff is implicit, but it's super important.
Yes.
Like Litfic has this, code has this in a completely different way, but it has sort of the same problem where like somebody who wrote a piece of fiction has like the words they're using, the phrases, the expressions, the scenes all have these connotations to them. And a good author is somebody who can write in a way that is able to evoke some of the same connotations in other people. So they're able to be somewhat universal in what they elicit so that people get at least one of the things they wanted to get them out of it. Or maybe they get something different out of it because like the writer is just like, from a craftsmanship perspective, just they know what they're doing and they're writing in a way that even if it's not exactly the thing they wanted to say, like they're trying to be careful in what they're doing so that maybe you get something else out of it that's equally valid. Code is somewhat different in that code is really a more objective thing. Like literature is a lot about subjectivity and subjective experience. And with code, there's actual like measurable, provable properties in a way you don't have in fiction. But it has a lot of the same problem of like, oh, there's these things not being said. You need to keep track of this in your head. Some of these things may allude to other things in parts of the code base you're not even aware of. Like this only works because the operating system memory manager does this, which you may not know when you're reading the code, right? You have all these implicit dependencies, and it's complicated. So reading code is really, really hard, but at the same time, the answer to that can't be to not read code because it's difficult. We need to figure out a way. Like, there's a lot of this knowledge out there. Like, and if you look at like there's a lot of easy things to say to dismiss, say, databases. Oh, databases are slow and boring, whatever. If you look at how an actual database engine is interested, that tries to like juggle all these intersecting concerns, and while also trying to be safe under adversarial circumstances that nobody else ever has. Like a database tries to make very damn sure that even if the power goes out, like in 5 seconds, that stuff that's on disk is still completely valid and recoverable. And some of the stuff you did that didn't fully get flushed to disk may not show up in that database, but the view you get of that database is still consistent. It's a consistent version of a bit earlier. Like databases do all these kinds of things. Other software systems have other things that they do that are really interesting and really hard problems that these people have really, really thought about and that everybody just takes for granted. And you can easily do a shitty database that does the query processing correctly, but doesn't give you durability or atomicity or consistency, which is one of these things that like classic like SQL style databases care about. So there's a lot of stuff there going on in that code that is really subtle, really interesting, and it's written by these people who are really, truly experts in their field, who really know what they're doing, who've been thinking this for a long time. And so like, a lot of the code they use that is widely used is written by people who really knew what they were doing in a lot of different ways. And that's something worth considering. And it's worth looking at that code and see, can I learn something from that? And it's not about like you should be reading code or like reading quarters or whatever, but like if there's a program you use that works for you, and that may have some of these things, like I recommend looking into that code to see like what do they care about, how do they do these things, like this thing that I just noticed that this thing does that's really sort of non-intuitive and complicated, and they seem to do that gracefully. How does that work? And there's actually, again, with the internet, there's a lot of ways to learn about how these things work, how this is done. Like there's good literature out there. Many of the best programmers are extremely literate people in the sense that they are good at writing this stuff down. They have specs. They've written papers about it. Like some people like Don Knuth has written Tech, which is his typesetting system, in this ancient dialect of Pascal. But the whole program is what he calls a literate program, which means that it's text interspersed with a program, and he explains the whole thing. If you want to understand that program, there's a complete book that literally explains every single line in that program, and not in the crappy comment like x++ comment increment x by 1 way, but in a way of actually communicating the fundamental dynamics of what is going on. Like you will actually understand the algorithms in that program. And like that kind of stuff is out there. And some of these are my favorite books. Another one is a retargetable C compiler, design and implementation. Is a book about the C compiler LCC in version 3.
Yeah, I've heard of that. Yeah.
That book is a great book. It's not a modern C compiler. It's a one-pass compiler, which is the way like old school compilers, like including Turbo Pascal, used to be. It has to do, like it reads the whole thing. It generates the code while it's reading in the code, basically. Like it never keeps more state than a function at a time. So there's limits on what it can do in terms of optimization. But LCC is actually a really interesting C program, and is a short C program. It's something like 11,000 lines for a single backend. So it's really not that many lines of code. There's a whole compiler in there. And you see this book that discusses how that compiler works. And at the end of each section, like here's how we do memory management, here's how we do parsing, here's how statements work, here's how declarations work. At the end of every section, there's like, oh, look at this thing we do in that part of the code. Doesn't that look like it might be a bug? Can you find out why that is that way? Or like, what are the design trade-offs here? It's like there's exercises in that book. It's like a textbook that actually asks you to engage with this code in interesting ways and like consider like, what are the design decisions here? Or why does this work? Or why does this not work? Or gives you like further references like, we do this here because it's the simplest way to do this in our framework. But if you did this differently, it might look like this. Like all these kinds of things are super valid and super interesting. And I can, like, if you're interested in this kind of thing at all, I can strongly encourage you to seek out books like that. The tech book is one about tech. There's the LCC book. There's Matt Farr and somebody else's wonderful book, Physically Based Rendering. Yeah. That is also a literate program of a physically based ray tracer. There's not that many literate programming books out there that are engaging with the program in that way. All of the ones that I've seen are spectacular and absolutely worth spending time with, because they do not give you just a code dump. They give you enough to actually understand what is going on in that program, which is just amazing. And which is important, because that's the thing, like if you're trying to maintain a code, that's what you don't have. You have all these lines of code, but you never have the context. You don't know what they do. And half your work is just figuring out how these pieces fit together.
Nice. You know, okay, I like that. You know, the community, well, not everybody, but there are some people in the community that are just outright dismissive of whatever's out there because of the bad experiences they've had with some libraries, right? Or with some pieces of software. But obviously what you brought on the table is absolutely true. And it's something that I hope the community has taken a positive liking to. And with that, Fabian, are you ready for the Q&A?
Sure.
All right. This is the last part of the stream. Let's answer some questions. So there are a couple that are the same, so I'm going to smash them together into one. But Captain Craft asked this, Fiolcon asked this. It has to do, I guess, with the Windows debugger. So this is quickly a technical question right here.
Okay.
What do you look for in a good debugger? And I think they're assuming that the one in Visual Studio is not the best. It's just the only one that they have at their fingertips. But
I'm not really a debugger power user.
Okay.
And generally in programs, I'm not the kind of person who has super customized IDEs and macros for everything.
Gotcha.
Basically, in any program, I care much more about them getting the basics right and the basic workflows of what I'm doing to be non-frustrating than I care about any specific fancy features. What I want in a debugger is fairly simple. First off, I want the symbol resolution to actually work. I want to be able to see both the compiled disassembly, and I want to be able to go to the source, and I would like them to match if possible. That would be great. I would love for watches and expressions, that kind of window, that is something I use a lot, so I like that. I want to be able to inspect things and have that work properly. Single step, that kind of stuff, all needs to be there, all needs to work. And a memory view maybe, data breakpoints obviously and regular breakpoints, but really the basics. These are all features that were already in Turbo Debugger in the 90s. If a debugger has that, that is most of what I want out of a debugger. There's added value you can get from going fancier than that, but really once that's there, I'm good.
Okay. Yeah, cool. All right, well, there you go. And something related to tools and debuggers and stuff. This one's pretty cool. I'll separate it into two parts. The first question is, I knew this was going to come. What do you think about Jonathan Blow's JAI language? That's the first part. And the second part is, what is your most wanted tool or language or thing in general that you want, but you don't have? And this comes a lot because, we have over 200 viewers here, and we all want to make software for people that we respect. So we asked this question to Sean, we're asking it to you now. What kind of tool would you like us to make for you, because you don't have the time to, right? So those are the two questions, so go ahead.
Okay, on John Blow's language, which I'll just call Jai. I'm not sure if it's JAI or Jai, but I'll just call it Jai.
Jai is faster. Yeah.
Okay. I don't have any strong opinions on it at all. It looks interesting. I haven't written any code in it. And I find that the opinions of people about languages that they haven't written code in aren't worth a damn, really. I mean, seriously, what am I supposed to say here? Yes, it looks interesting. I would certainly love to spend time with it. Ask me what I really think about it after I've actually tried to write a program with it. Right now, I can speculate. There's things in it that I like. There's things that I'm not sure about. And whether it actually works or not, I'll only know after I've tried to write a program in it, really. That's all I can say about that.
Fair enough.
As for what tools would I like to have, that was kind of hard. It's easy to say I want a unicorn basically, but a more specific thing of where you just go away from I want the thing that is designed exactly for me in all things, and try to go a bit more towards the realistic, where's a tool-shaped hole in my workflow, and what tool might conceivably fill that? That is considerably harder. One thing that I certainly would like to have more, there's this whole thing about where people refer to C as a portable assembly language, and that is not really the case. C is a low-level-ish language, but the compilers are forever trying, because the compiler writers, again, are stuck with lots of existing code that was written often for architectures that were very different from what we have now. What I would like to have in the abstract is something that actually tries to be more like a portable assembler, and that there's no fancy optimizers there at all, really. There's some very basic stuff, but mostly uses for for things that are actually inner loops, where you actually might specialize that kind of code for multiple architectures, for example, in ways that are actually different. And what I'd like for there in this tool would be something where I can write just a generic version that's just slow and interpreted, that specifies the behavior I want, and then some way to actually generate, say, assembly for multiple different target machines, without me having to actually do register allocation and so on completely by hand. I've done a lot of assembly writing. I don't care to do any manual register allocation in my life anymore. It's a thing, you can do it. It's just a chore to maintain. And what I'd really like is something that automates some of these chores for me, but at the same time still gives me a lot of control about the code that is being generated, and has the tooling necessary to verify that whatever fancy code I happen to be writing actually matches the behavior I would like it to have. That is written in a straightforward way. But that is mostly because of the kinds of use cases that I happen to deal with a lot professionally.
Yeah.
Like I do lots of random optimization stuff for RAD, where it's just like, oh, we have this FFT thing. It's like, yes, FFT kernels are kind of hot and say our audio codecs and so on. So you want that stuff to be optimized, and it needs to be on multiple platforms. But at the same time, like the first thing is like it needs to be correct. Like that is the first thing. Like a lot of people write fast code that is sort of right, and I don't believe in that. Like you can optimize all you want, but the most important thing is that your code still like does the right thing, or at least a right thing. Like lots of people optimize code and then sort of cut corners.
Yeah.
They're not really sure what it does in some of the corner cases that the original code handled.
Uh-oh.
And that's not okay. Like I need to know what that code will actually do in the cases where it'll be used, or I'm not comfortable shipping that in a library to customers. If it was my own program just for my own use, I might not care. But at RAD, I ship this library code to others, and it's not okay for me to be mystified by what the FFT code is doing ever. So like that kind of thing, it's just I need to be able to actually trust that the thing I do, at the very least, has the infrastructure to test that these optimized implementations actually do the right thing. And I feel like there's something that a language, that there's a niche that a language could fill, but that's really just a feeling, and it's hard to point a finger at it. And if you talk to actual compiler devs, they'll tell you like, oh, what do you want out of this is completely crazy. The thing is, like, the thing I want makes a lot more sense if you're coming at it from the LCC like one pass compiler model. Yes. And if you're in a more modern compiler that tries to do all the more complicated like SSA data flow and like global optimization kinds of things, it is absolutely horrible. You don't want to do that. But it feels like there's a niche for a tool that is higher level than assembler, lower level than the C and C++ compilers we have, and is actually designed to allow you to do these things and do things that you wouldn't want to do in normal C code, where you actually like tweak or at least have some specification of like, we do this slightly differently on different architectures because the schedule's better and so on.
Yeah.
Trying to do that through a compiler that reorders your instructions is just madness. Like you don't want to be there. But it seems to me like there is a space there where you could conceivably have that kind of tool. Just we don't have them yet.
Okay. All right. Good answer. I'm gonna pick. Let's see. I wish I could comment on everything you're saying, but we are running out of time. So what we're gonna do is, well, first I'm gonna ask you if you can hang around in the chat for a little bit after the stream.
Of course I will. Yeah.
All right, because there's gonna be a lot of unanswered questions. There's a shit ton of them. Since I wanna clock out at 7:30 EST, I'm gonna pick up 2 more questions, and then we'll have some closing remarks. So this next question comes from Chrono Dragon. He is one of the lead developers for the website. He's asking, Fabian, have you kept up with modern demo scene? And do you think it will be still worthwhile to try to learn demo scene techniques?
I have not been keeping up with the demo scene much.
Oh, interesting.
I'm still friends with a lot of people who are active in the demo scene, so it's not like it completely passes by me without me noticing, but I've not been very active since about 2010 or so. That part of traces back to the burnout thing I mentioned that happened in 2007. So what was there was just way too much going on. I had the university stuff and the product stuff and various other things going on at the same time. And that's when I basically got in a state of like, I need to do less programming. And ever since I've been like, okay, it's totally fine to do programming at my day job. But I just noticed like if I also do a lot of programming like on the side, like that just wears me down really, really badly. So that's when I stopped being very active in the demo scene at some point in like 2009. I told people like, okay, there was this demo we were working on. It's like, okay, like I don't think this is good for me anymore. I need some distance from this because it's just like at some point it felt like the whole demo scene thing was more stressful than my day job, which is just crazy. And that's when I said like, okay, I need to get out of there. I still notice what's going on. I can't really tell you what the right way to get into it is. One other thing that I didn't get into, but that's sort of important to understand my perspective, is that starting from 2001, I've also been co-organizing demo parties until 2010. Like starting in 2001, I was an organizer at Meccan Symposium, and then later the demo party Breakpoint. And so I have a couple peeves with the demo scene, so to say. And one of them is that there's just a large community of people in there who would rather we stick to platforms like C64 and Amiga exclusively, more or less. And like everything on newer platforms is crap because they're not that direct anymore and don't allow you to poke around in the hardware and whatever. That's not a large subset necessarily, but they're very vocal. And I've had to deal with a lot of these people, and it's kind of frustrating. I love demos that push these really old fixed spec machines and do new things that people didn't even know were possible. It's kind of hard to even understand what they're doing if you're not intimately aware of the limitations of these machines, but it is definitely cool. That said, like that whole attitude just leads to excluding people who didn't grow up with these platforms in the first place. And that's certainly a thing going on in the demo scene where it feels like as long as I've been in the demo scene, the average and median age of a demo scener has been going up by 1 year for every year. And that is a clear sign that you may be losing touch with the world out there. There were a couple things I was trying to do around 2009, 2010, where I felt like, hey, we can try to like, hey, maybe go co-locate with, say, one of these hacker conventions and try to recruit our kind of people there and like show people that this kind of stuff is out there and get some interesting perspectives from people who aren't in this totally retro mindset in here. That's kind of a hard sell. And again, I'm oversimplifying here, but I've got kind of frustrated with the whole thing. So, which is why I got out of party organizing too.
Okay.
In addition with me just being on another continent, which doesn't exist.
that puts a hamper on things too. All right. Our last question comes from Sergio. Let me see if I can find it because I had to scroll down and ban some people. All right. Search RGB. So Fabian, how much speed up does the code you write gain from your compiler? From general compiler optimizations. He has the impression that your release builds are not much faster than your debug builds.
Oh, that's not true at all.
Oh.
It's impossible to put a general number on that.
That's true.
In general, how to phrase this? Okay. The kinds of stuff that compilers do and are kind of required to do, that's the only thing they really can do, is let's call them tactical optimizations.
Okay.
If you look at this relatively isolated piece of the code, because it turns out, like, from a purely computer science perspective, just like even mathematical logic, like knowing anything interesting about programs is ridiculously hard. Like even like trying to discover like, is this a sort, and like trying like the whole sufficiently smart compiler thing, which is one of these phrases, like the sufficiently smart compiler that detects that you're trying to do a sort and replaces your bubble sort with a better algorithm. That's kind of the caricature of the thing. That's not really something that compilers can actually do. Like fundamentally, like proving that something is a sort runs into really, really, really hard, unsolved, and in some cases, and actually in most cases, like unsolvable in the sense of mathematically undecidable problems. So what compilers actually do is take your code that you write and apply this long sequence of transformations, all of which like have different purposes. Some of them just try to take all the ways you could write a program that are equivalent, like they're expressing exactly the same thing, exactly the same sequence of operations in the end, but in different ways. And one thing that compilers try to do is, if they can, try to boil down some of these variations to a smaller number of variations, simply so that if another pass after that tries to figure out like, oh, this is trying to do an indexed array access, like they now look in a certain way. And it's not either pointer arithmetic or an indexed thing. Like, no, if this can be written as an indexed array access, we try to always write it that way. Like there's transforms like that. There's transforms that try to like change your loop structure, which are some of the fancier transforms. There's lots of very basic things, like conceptually basic things that are still super important, like just register allocation and scheduling, as in selecting what runs where. The details of scheduling is in an out of order CPU, is mostly handled by the CPU itself. But there's another concept, key component of scheduling, which is just like, oh, how many of these kinds of resources am I using at what point in time? And do I opt to use more resources right now so that I can get more parallelism on the CPU? Or am I actually running low on these resources? And do I want to write the code in a more serial way so that I don't end up, for example, spilling a lot of registers to the stack because I'm out of registers? So there's all these kinds of things that compilers do, most of which involve solving ridiculously hard problems. And compilers really care about these tactical things like, oh, we take this loop and apply this mechanical transformation that we happen to be able to prove is fine, assuming that the language spec is correct, that the programmer actually wrote this thing, having read the language spec and knowing all the arcane rules that are in there when it's allowed to do certain transforms that would otherwise be illegal. It's like, this is kind of this unhappy place that they are, where a lot of the things they would want to know, they really can't know unless they have these very specific rules that the programmer really needs to be aware of, which they often aren't. So it's an unhappy situation. But the kind of things they try to do is of that nature. Like they basically try to detect a certain pattern, match it, and apply some transform. That's always what they do on multiple different levels. And some of these things are like literally just pattern matching, and other things transform these into very general mathematical optimization problems. Like, oh, we have this cost function that tries to capture the thing we're going for. And of all the possible ways to turn this representation to this representation that are theoretically valid, we try to select the cheapest one, for example. So that kind of stuff is in there too. But none of the things that compilers can do are really that wide-reaching in your program once you get down to it. It's like the biggest wins you get usually in a program are not from locally selecting better instructions. There's some win to be had there some of the time, or just from using SIMD code instead of scalar. That can be a good win sometimes, and it's often a really bad idea. If the thing you happen to be looking at isn't actually something that vectorizes well, and then it might be slower. The really important thing in programming has, if you care about performance, usually has nothing to do with that level at all. It's about structuring your program so that the data is in the right shape at the right time. If your data is in a mostly array kind of fashion, that means you can SIMD it well. But it also completely independently means that a regular optimizing compiler will look at that and be able to prove certain things about it that otherwise it can't. Like if you do a flat iteration over an array where you modify some things, even if you never SIMD it after that, it's still gonna be usually faster than if you were chasing a lot of pointers around, for example. And some of that has to do even with things like cache misses and so on. Like lots of people also get way too hung up on certain microarchitectural details. It's kind of important to know what caches are and what the basic idea is. I am a huge computer architecture nerd. I know way more about this stuff than anybody sane who's not actually doing hardware design should know, probably. But I just like, it interests me. So like I spend time learning that stuff, but you do not need to be up to date on that stuff. Because fundamentally what you learn is that in modern microarchitectures, if you're aware of any of the various things they actually do to interpret the high level concepts, you're running into a case where the chip is screwing up. Like, and hardware engineers will basically tell, like, if you need to optimize that hard for something that specific that might change in the next generation, like they basically consider that a bug. Like, this exaggeration, but that's basically how it is. Like, you should not need to know exactly how the nuts and bolts of that processor work to optimize for it. But you should know what a cache is. And you should be worrying about what the patterns of data flow are and how often you copy data around versus leaving it in place. Like, copying data, if you just do it willy-nilly, is basically always bad. But if, say, copying data allows you to do stuff on multiple threads, it might be good. And like, these are more high-level trade-offs, but you need to be aware of them. And that's if you care about performance, like knowing about that stuff, knowing some very basic ideas of how caches work, being aware that, say, in a multi-processor system, that memory is not just magically shared, but that it basically works by basically assigning each processor parts of memory that it currently owns. And every processor can only write to memory that it currently owns. Like, reading can be shared, but writing means that you have to currently own it and transfer that ownership back and forth. And that is an expensive operation. Knowing that that's what's going on is way more important than knowing any of the details about how these things are actually implemented under the hood. That's interesting, but it's not important to actually writing the code. Knowing what the thing that the physical machine is trying to accomplish is way more important than the details of how it's trying to accomplish that. So I'd always try to have an understanding, not of the particular details of any given machine, but of the actual high-level goals that it's trying to achieve with the things it's doing. Because that's also, that goes into a lot of I have a lot of frustration with people who are very low-level optimization heavy and have that viewpoint exclusively about everything. Mind, I often do low-level stuff that is sort of crazy and that nobody in their right minds should be doing. And it's in like compression code, like, okay, like we want to process a gigabyte a second, and then you start doing things that if it wasn't a 100-line piece of code that is totally self-contained, you would never consider. Because it is a 100-line piece of code and it is self-contained, and you're shipping that to a couple thousand customers, so it actually matters. But generally, I would not worry about these kinds of things. And there's people who are like, oh, like I do this kind of optimization stuff all the time, and this should be a framing perspective for everything. And that's just not true. Sometimes optimization is really important. And like some optimizations are basically impossible to do unless you've planned for them. Like restructuring the high-level data flow in a program after the fact is a real pain, and you don't want to be doing that. But at the same time, designing your program from the top so that everything is just written with the goal of ultimately SIMDing this one loop, that's also crap, because that locks down so many details and forces you to make so many decisions way ahead of time that like you're thinking about that one loop and you're spending so much time on that. And in fact, there's a lot of other things going on in that program that you also should be worrying about that are now not getting the attention they should be getting. So it's complicated.
Wow. No, I wish I could continue talking. Now, hopefully I can have you get on the show.
Sure.
We've covered so many things.
Mm-hmm.
That broke my mojo. Damn it. I'm sorry, guys. I'm sorry. That was weird. All right. So what I was telling Fabian is that I hope to have him on the show again, and he said yes. which is very exciting. And I'm just giving him one last question before we end the stream, and then he can go on the chat and answer all of the questions that I skipped over. I know it's a lot of them. So once he leaves the stream, have at him, okay? So Fabian, a lot of the community here, a lot of people here are young programmers who look up to you a lot. So if you could give them one piece of advice of how to, I told this to Sean once, he didn't really reply. Maybe you can give us some advice of how to become better programmers as we age. What things can we do that worked for you maybe and might work for us in order to become a more experienced programmer? Like, what kind of advice would you give us?
There's really two things.
Okay.
The first thing is not to get too fixated on any particular view of the world and any particular strategy for solving problems. This is something you see a lot with some people who, get caught up on the latest new thing. It's like, oh, we're doing Agile now, or we're doing test-driven design. And what you'll find, or extreme programming, or whatever the current fad of the day is, what you'll find is that all of these people have a point. But you'll also find that none of these things are ever quite as universally applicable as the people who are shilling them think they are. Like OOP, for example, like there's some general problem with the OOP, where like if you ask, say, what is structured programming, pretty much everybody will agree on what that is. With OOP, you get a different answer from every single person.
For those who don't know, OOP is object-oriented programming, right?
Yeah.
Okay,
yeah.
Go on. Yeah.
And what that's telling you is that there's some of these concepts in there, and like people will tell you like, oh, it's about data hiding, or it's about modularity, or it's about having clean separation between interfaces, or it's about this model of thinking about entities that are passing messages and so on. There's all these kinds of different things. And you can ask like 20 different people from different backgrounds what they think the core of OOP is, and you'll get very different answers. Like that tells you that really like people are talking about object-oriented programming as if it's a thing, but really it's multiple different things to different people. So there's lots of talking apart going on there. And what you'll find is that each of these concepts is actually a super valuable thing it's a tool. Like these are all tools. Like virtual functions are a tool. Template metaprogramming is a tool. You can decide for yourself whether this is a tool you want to use or not, whether it's applicable or not. I tend to use basically almost all the things that are offered in some form, at least in some code. I'm not like Sean, where I really restrict myself to say C exclusively. I've written a lot of C or C-ish code at Rad because a lot of the code base is C. And then say, for example, Charles in Oodle has a code base where he uses a lot of C++, and then I use C++, and it's fine. I don't like the mindset of C++ programmers who see the way that certain ideas are expressed in C++ and take that to be the natural expression of that concept. Because the C++ is that proverbial dog that somebody has turned into an octopus by nailing extra 4 legs on, right? It's this really weird thing. And like basically nothing that currently is in C++ I would really call the natural way to do that thing. It just happens to be there. And you get some benefit from these tools. And then people will tell you there's these things called zero-cost abstractions, which is a term I hate. Because like, no abstraction is actually zero cost. Like the only way for an abstraction to actually be zero cost in your program is for it to not be there. And that's not in the sense of like, you should not abstract. It's in the sense like everything you put in your program, whether it's implicit or explicit, has a cost if it's in there. Like either it's a cost of understanding it. Not having it might have a cost too. But like, this is an engineering discipline. Like we're making trade-offs. The ability to understand something is important, and abstractions help us managing things that are too large to fit into our heads into manageable pieces. But do understand that in breaking these things down, maybe generalizing them or simplifying them, we lose something. Like there's the most important thing to keep in mind, I find, as programmers, we're in the business of solving very specific types of problems, right? And our instinct is to always solve these kinds of problems by writing programs, because that is what we do. Some of the problems that people are trying to solve by writing programs maybe should not be solved that way at all. Like maybe sometimes the right answer is to just like have a filing system with like 3 index cards in a cabinet, because like you didn't need a SQL database and a front end for that, for example. And like that kind of generalizes to different sorts of things. Like people get too hung up on a particular view on a problem, or a particular understanding, or a particular methodology, or a particular tool. Like you have this massive tool chest. Like there's all these kinds of things you can do. And a lot of these tools are really good. Some of them aren't, but oh well. But there's all these tools at your disposal. And your job is not to just say like, I'm the hammer guy, and I'm gonna use this hammer for everything, man. And then try to solve with a hammer, and it really doesn't work very well. Like your goal is to look at the problem, like the actual problem.
In reality,
not the thing that you think the problem is. Your first goal, which a lot of people already fail at by not trying to allocate enough time to it, is to actually understand what the problem is, which is often completely different than what you first expected. Like because you get something like from a customer, like I want to do this thing, and which is this very, very harsh thing, like a very vague goal. And then they have this crazy sequence of workarounds, and we need this specific thing, and it's this really odd feature. Once you ask, you learn that what they actually need solved is a very different thing than the vague description, and it actually turns out to be way easier to accomplish in a completely different way than what they asked for. And it is not insane. It does not require this Rube Goldberg device, right? So like your first job as a programmer is to always understand what the actual problem is. Not what you think the problem is, not what the customer may have thought the solution is, but like first step is to actually formulate what is the actual problem I'm trying to solve. Like be aware of what the problem you're trying to solve even is. Do not start writing code and then figure out what the problem is along with figuring out the solution. That doesn't work. So what you really need to do is be critical of your own thought process, right? Understand, like try to keep yourself honest. Because what people end up doing is you draw, like you're trying to gather data, right? And you're drawing this map of the problem domain.
Yeah.
It has all these features. And after that, you just only ever look at the map and you never look at the actual problem again. And that might make you miss the thing that was the key to the whole solution. Because you're now only looking at the map, at your mental model of the problem, which might not have been the actual problem. And a lot of the APIs are even worse. Not only are they not thinking about the actual problem they're trying to solve, and like that's, by the way, like that is the sign of a bad API, or one of the key signs, is if the answer to what problem does this solve is actually unclear. And I don't mean like wishy-washy kind of thing, like this is trying to be an architecture for extensibility is not a problem. Like that's not like, what is the thing you're actually trying to achieve? Like these are just weasel words, right? They can mean anything.
True.
You need to have a concrete thing, like what is this thing trying to accomplish? And it might do that or it might fail at it, but you need to have at least an answer. And the second most common thing that APIs often do wrong is that they have that problem and they decide on the solution. And then everything in that API is framed not in terms that make sense for the problem, but in terms that make sense in terms of the solution. But that is wrong. Like if you think about it as a module, that is, you want to do something, somebody has a problem that they want solved, and they're calling that module. And what that module ought to be doing is take their problem and transform it into a solution. If you need to become an expert on how exactly that kind of problem is solved, in order to be able to use the library in the first place, that library has failed at trying to be something that is actually useful to people. Yeah.
Nice.
So that's my answer, long-winded answer to that kind of thing. So like really like try to keep your perspectives open and like try to understand what is the actual problem. And like basically it boils down to like actually think about what you're doing. Not in the sense of like overthink every single thing you do, but if somebody asks you like, why are you writing that code that you're writing? What is that even doing? And you don't have an actual answer to that, that's a warning sign. If you're just throwing stuff together to figure out what works, I mean, if you're doing an exploratory thing, that's fine. But if that's code you're actually intending to ship to somebody, that's not good enough. You should have an answer.
Nice. And I always tell people, if you want to be able to do what you just said, something you could do is get into the space exploration industry like I am in. Because if you want to launch a rocket, then you kind of have to force yourself to actually understand the problem to launch the rocket successfully. So the stakes are so high that you kind of have to force yourself into that mindset, usually.
Yep.
So
it's also just like, so I do a lot of optimization stuff for rad.
Yeah.
And I have this sort of mystique, like, oh, he's the guy they call in to do optimization. There's a lot of competent people at rad.
Yeah.
One of my biggest assets at rad is that I'm not tied to any particular product. So what happens? It's like you have a particular problem that you're grappling with. Like that's some performance problem. And then at some point, like I get called in to maybe help out on that. Big part of the value you bring in is just that I'm not you. Not because you're bad, but because you have been staring at that problem for so long that you were sort of locked in your thinking.
Yeah.
And I can bring a fresh perspective.
Tunnel vision.
Maybe try to understand what's going on there and ask a question that makes them realize like, oh shit. Like, so like just coming in there as somebody who does not own that project, who does not have it all paged in his head.
Yeah.
And then asking a question that makes them realize like, wait, maybe I'm overthinking this. Like that is like a lot of the value you can offer. And it has nothing to do with being super good at micro optimization. It's just about not being the guy who's been staring at this for hours, right?
Yes. Fresh perspectives. Go ahead and play the witness, people, if you want to have fresh perspectives. So, Fabian, thank you so much. Like, this has been one of the most amazing conversations I've had, along with you and Sean Barrett. Like, it's been amazing. Thank you for being here.
Sure.
So I hope you can hang around the chat because there's a lot of questions that they want to ask. So get ready.
Yep.
All right, and I'll have you again on this on the show, especially once we launch the website and you get to see some of the projects that we're doing and have you comment on them and things like that. So thank you again, and why don't you go ahead? You can leave the Hangouts call if you want to. I'm gonna make some final announcements, and I'll see you in the chat. Thank you again, man. This was awesome.
Okay.
All right.
Bye.
Bye-bye. Guys, this has been one of the longest streams that I have done on the Handmade Dev Show, if not the longest. But boy, oh boy, have I learned so many things. I don't know if you saw me. I was like that for minutes on end or times on end. So I'm going to have to rewatch this a number of times to sort of absorb some of the things that Fabian has talked about. Thank you guys for being here. Next Saturday will be the last episode to close season 1 of Handmade Dev Show. So next Saturday, one more episode, and then I'm going to take a 1 or 2 week break. If you've noticed, all of the people that I've had here on the show have been on the game industry, right? Games primarily, which has been fascinating. But you know, season 2 of the Handmade Dev Show will have people not only from the game industry, but from the space industry, SpaceX, programmers from vastly different problem domains to sort of give their perspectives as well. There's not a single place that I've seen that just does interviews, hopefully quality interviews of programmers, of successful programmers across many different problems domain, and I hope to solve that. So next episode, I wonder who I'm gonna have. If you wanna find out who my next guest is going to be, oops, oh my, if you want to find out who my next guest is going to be, go ahead and follow me here at Abner Coimbre. And I will see you guys next Saturday.